Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Welcome back. Problem 5-2. This problem is same as 5-1. The solid shaft of radius r is subjected to torque T. Determine the radius r dash of the inner core of the shaft that resists 1/4 of the applied torque, that is T by 4. Solve the problem by two ways, using torsion formula and B by finding the resultant of shear distribution. So first we will solve by using torsion formula. So you can see from figure that this is a shaft having outer radius r and inner radius r dash, and torque T is applied. Clear? And it is asked to find that r dash where the torque is T by 4. So as we know that shear stress tau is equal to T into C divided by Jp, where T is torque, C is distance from center to anywhere where you want to find the shear stress, and J is polar moment of inertia. So for C is equal to R, which is maximum radius, so shear stress will be maximum, so tau max will be equal to T into R divided by pi by 2 R4. For radius R, J will be equal to pi by 2 R4. So from this we will get tau max, and this tau max will be equal to 2T over pi R cube. This is equation number 1. Now it is also given that at the radius of r dash, this torque will be equal to T by 4. So again what we will do, that tau dash or tau shear stress at r dash will be T by 4. Clear? So we will put the same equation, the value of T by 4 in this equation. So tau is equal to T by 4, and this C will become equal to r dash divided by pi by 2 r dash 4. If you further simplify it, this torque, this shear stress will comes out to be T over 2 pi r dash cube. So this is equation number 2. Now we know that this tau over r dash is equal to tau max over r. There, so tau will be equal to r dash over r into tau max. This is our equation number 3. So what we will do is put equation 1 and 2 in equation 3. We will get this T is equal to T over 2 pi r dash cube, and is equal to r dash over r, and this tau max is 2T over pi r cube. So 2T over pi r cube. So if you simplify it, you will get this r dash will be equal to, okay, T will cancel with this T. Clear? Pi will cancel. Clear? And we will get this r dash will comes toward that, so it will be equal to 1 over 2. This 2 will also come over here, so 1 over 2 multiplied by 2 into r power 4, r dash power 4 will become equal to 1 over r4. So from that we will get 1 over 4 r dash power 4 is equal to 1 over r power 4. We are interested in to find r dash, so this r dash power 4 will become equal to r power 4 over 4. And again for finding r dash, so r dash will become equal to r over 4 power 1 over 4, and this r dash will become equal to 0.707 times r, where r is the outer radius and r dash is the radius where torque is T by 4. Now we will move toward our second method, that is to find the finding the resultant of shear stress distribution. Resultant of shear stress distribution. So if you look at the cross section of the shaft, it will be like this one. That this is the shaft ring center, this is the outer radius which is r, clear. And if you take a differential area, if you take this differential area of the shaft, here let this is differential area dA, and this area is located at a distance of rho from the center, and let this thickness of this will be equal to d rho. So from here we will get this differential area. This differential area will be equal to 2 pi rho into d rho. Okay. Also we know that this tau is equal to r dash over r max. We will write the general formula. We know that this tau is equal to rho over c into tau max. There. So for c is equal to r, we will have this tau is equal to rho over r here, and tau max is given as 2t over pi r cube. I will write it 2t over pi r cube. Now you can further simplify it. I will write it. This is the final equation will be like this. It will be equal to 2t over pi r4 into rho. Now for this differential area, the torque, the shear stress will be acting like this, perpendicular to this. So due to this shear stress, there will be a torque there, and this differential torque dt will become equal to rho times t tau into dA. Tau into dA is basically the shear force, and multiplied by the perpendicular distance, which is the rho, will give you differential torque. So now you can put the value of this tau from here. So dt is equal to rho into 2t over pi r4 into rho, and differential area dA is 2 pi rho into d rho. Clear? This is the equation. If you further simplify it, so dt will become equal to 4t rho cube d rho over r4. Now if we integrate it from 0 to t by 4, because at radius from 0 to r dash it is t by 4, so we will integrate it. It will be t from 0 to t by 4, and this will become equal to 4t over rho r4 into integral of 0 to r dash rho cube into d rho. Now you can integrate it and you will get the answer t by 4 is equal to 4t into r dash 4 over r over 4 divided by r4. Further simplifying will give you the same equation, that r dash power 4 is equal to r4 over 4 power 4. If you further simplify it, r dash will become equal to 0.707 times r. So it will give you the same result. I hope you have understand it. Thank you for watching.